Hi, I'm James. I did my research on the problems with the delay in Mars communication from Earth to Mars. And my idea was to see if NASA could create a satellite between the two planets so that information can travel quicker. And it would act as a intermediating decision-making satellite with people on board that can make decisions and relay them to the astronauts on Mars without Earth consent. And my plan is to name the satellite, list its specifications, figure out where it'll be placed, and then when the rocket should be launched, and how effective it will be in reducing the amount of delay in communication. And I named it the Mars Earth Communications Emergency Satellite. And for every 1 7/8 revolutions around the sun of Earth, Mars, I figured out, makes 1 revolution. So using that information, I had to find the average speed of those two planets to figure out where the satellite would be placed. And that came down to 2.881, which means that for every 2.881 revolutions around the sun, it becomes for 1 satellite revolution. And then that came down to 526 Earth days for the satellite. And then to figure out where it'll be placed in space, I just gauge it to a common body in space. Since Mars and Earth are always at differing locations or distances from each other, so I used the distance of Earth and Mars from the common object of the Sun and found the average of those two and figured that the satellite should be 188.75 million kilometers away. And then if we were to launch the SLS rocket at a time that would be convenient for the satellite and the rocket, we should do it in a time where the two planets are very close together, which is around 60 million kilometers is probably the closest that we can usually get. And since we don't know what year we'll be launching it, I just use the theoretical year, which is the next time they'll be the closest together, which is in 2018. And between the dates of July 27th and August 12th, it will be 60 million kilometers away, the two planets. And at that distance, it would take 88.75 Earth days to get the rocket at its full speed to get to the other planet of Mars from Earth. And I had to work back from that, the date in which it would be that close together to figure out when it should be launched. And it came down to April 29th and May 14th of just the year 2018 as an example. And for the rocket, for the satellite, I used the International Space Station as a reference to how this satellite should be based, and it would hold up to 4 or 5 astronauts at one time with reinforcements and supplies for the colonists on Mars, and they could make sure every problem is diagnosed, and they could log every decision they make on board the satellite and relay it back to Earth after every day. And unless they really need something big to be consented by Earth, they don't need to always do it back and forth, so it can cut down the time in half. And because of that, not having to be the data have to be traveled back all the way to Earth, the delay in time, like I said, could be cut down in half, which is a lot different. Because going both ways, that would make it 10 minutes, and then 20 minutes for an answer to be delivered. And as of now, with since we can't go faster than the speed of light, it would be 40 minutes total, which is twice as long as the 20 minutes, and would be a big improvement in communication speed and could solve a lot more problems better. Yeah.